Mathematics class 11 chapter 11 conic sections. In the last class we have studied exercise 11.3. Today we shall study hyperbola. A hyperbola is a set of all points in a plane. The difference of those distances from two fixed points in the plane is constant. So hyperbola is a set of all points, the difference of whose distance from two fixed points will be always constant. That is called your hyperbola. In this figure you can see there are 3 points P1, P2 and P3, and there are two fixed points F1 and F2. Now we have to see the differences of these P1 from these two fixed points will be equal to the difference of the distance of P2 from these 2 points will be equal to the difference of the distance of this P3 from these two fixed point will be constant. Okay, and distance here we take as the higher distance minus the lower distance, right? So here P1 F2 minus P1 F1 equal to P2 F2 minus P2 F1, then P3 F1 minus P3 F2 equal to constant. Okay, see here written mathematically, P1 F2 minus P1 F1 equal to P2 F2 minus P2 F1 equal to P3 F1 minus P3 F2. If you join all these similar points, okay, then the curve we get, that curve is your hyperbola. The two fixed points are called foci of hyperbola. Midpoint of the line segment joining the foci we call it as a center of hyperbola. The line through foci is called transverse axis. Line through center and perpendicular to transverse axis is called conjugate axis. Its length is 2b. The point at which hyperbola intersects the transverse axis is called the vertices of hyperbola. The distance between the foci is 2c. Distance between the vertices, that is the length of the transverse axis, is 2a. And the relation between b, a and c is given as b equal to square root of c square minus a square. If you square this side, b square equal to c square minus a square. We can see in this is a center. Okay, usually we take as the origin. These 2 points are the vertex, or you call vertices. The fixed 2 points, they are called focus, and together we call it as a foci. This is your conjugate axis and this is your transverse axis. The length of transverse axis is 2a and conjugate axis is 2b. Then here you can see the distance between two focus, that is F1 and F2. The foci is 2c. The distance between the two vertices, here A and B are the vertices. The distance between these two is 2a, and the distance of, or the length of the transverse axis you call it as a 2a, and the length of the conjugate axis we call it as a 2b. This b is half conjugate axis, okay, semi, but total will be 2b. We said that the distance difference is constant from two fixed points. Now let us find that constant difference. Okay, to find the constant P1 F2 minus P1 F1. So this is the figure of the hyperbola. These are the vertices. These are the focus, or you can say foci. The distance from the origin to F2, the focus, we call it as a C. This is the length of the half semi length of the transverse axis, and this is the semi length of the conjugate axis. Okay, and the total length from A to B will be 2a, because this I am taking as A. So from here to here will be 2a. By taking point P at A and B, now we will take point P at A and B, okay, on the vertices. Then by definition of hyperbola, the difference of the distance of these points from the two fixed points, that is here F1 and F2, will be constant. So we take A F2 minus A F1 will be equal to B F1 minus B F2. Okay, see it is written here, this is by the definition. But B F1 from the figure, see B F1 from the figure you can say that it can be written as BA plus AF1. Okay, so I have written here AB plus AF1, and similarly AF2. So AF2 can be written as AB plus BF2. Okay, so AB plus BF2. So let us place the value. Instead of BF1 you put this value, and instead of AF2 you put this value. So here AB plus AF1 minus BF2 as it is equal to here AF plus BF2 minus AF1 as it is. AB cut, then AF suppose this AF1 transfer over here becomes plus, so it will be 2 times AF1, and this BF2 which is negative transfer over here becomes positive and it will add up with this, so 2 times BF2. 2 cut, so you say that AF1 is equal to AF2. Okay, so that is what we find here, that is AF1 equal to BF2. Okay, so now BF1 minus BF2. Okay, we go back to the difference because that is what we want to find. BF1 minus BF2 equal to BF1, again from here AB plus AF1 and BF2 as it is. Now AB as it is, AF1 as it is, minus BF2, from here you can write as AF1. So one is positive, one is negative, so they can cancel. So this remains AB, and AB, we know that the distance AB is twice A. So you can write that is twice A. So we have found the constant difference BF1 minus BF2 is twice A. Okay, that is what we have to find. Eccentricity E. The ratio E is equal to C by A is called the eccentricity of hyperbola. What is C? C is the distance of the one of the foci, or the distance of the focus from the origin, and A is the length, semi-length of the transfer axis. Okay, so E is equal to C by A, and this is called your eccentricity of the hyperbola. Now in hyperbola, C is always greater than or equal to A. Therefore, E is never less than 1. Then foci in terms of E. If you transfer this A over here, you get C value as A into E. So foci in terms of E is at a distance AE from center. Okay, from here you just transfer this here. So we can say the foci is at a distance AE from the center. Now we shall derive the standard equation of hyperbola. Let F1 and F2 be the foci and origin O be the midpoint of line segment F1, F2. Then F1 minus C0 and F2 C0. Okay, so we are taking the focus or the fixed point F1, F2 such that the midpoint of that is origin. Then we can say the coordinate of F1 as minus C0 and F2 as plus C0. So this is a foci F1 minus C0, and this is foci, and second focus F2 C0. Okay, and this is the origin which is the midpoint of F1 and F2. Let Pxy be any point on hyperbola such that the difference of the distance from P to the farthest point minus the closer point be 2a. Okay, now we take any point Pxy on the hyperbola. Okay, and by definition of hyperbola, the difference of the distance of P from the two fixed points, that is F1 and F2, from the further point minus the closer point, that is Pf1 minus Pf2, should be constant, and that constant we already proved that it should be 2a. Okay, so we'll take that constant difference will be twice a. Okay, so we shall write here Pf1 minus Pf2 equal to twice a. So by distance formula we find Pf1 and Pf2. So Pf1, if you find Pf1, it will be square root of x minus plus c whole square plus y minus 0 whole square minus the difference between distance between P and F2, that is x minus c whole square plus y minus 0 whole square, and all this should be under the square root. So I am writing here square root of x plus c whole square plus y minus 0 whole square minus square root of x minus c whole square plus y minus 0 whole square equal to 2a. Okay, this we already proved here. So we have proved here, so we are just using directly the difference will be 2a. So now we shall square both the side. Okay, but before squaring, let us transfer this negative term over this side. Okay, so this will keep as it is, y minus 0 whole square is y square, this as it is, and this you transfer over here. So 2a plus this minus becomes plus square root of x minus c whole square plus y square. Now square both the side. So when you square, the square root will cut. So you get here x plus c whole square plus y square equal to, when you square there are two terms, so you have to write 2a plus square root of x minus c whole square plus y square whole square. Okay, now I am expanding this using a plus b whole square, that is x square plus 2cx plus c square plus y square as it is, and this also you have to expand using a plus b whole square. So 2a whole square is 4a square plus 2 into 2a into this, so it is 4a into square root of x minus c whole square plus y square plus square of this, so square root will cut for the last term x minus c whole square plus y square plus y square, and this plus y square you can cancel. Okay, from both the side you can cancel. So here you get x square plus 2cx plus c square equal to 4a square plus 4a under the square root x minus c whole square plus y square, and this I am expanding using a minus b whole square. So x square minus 2cx plus c square, and this y square already I have cancelled with this. Now let us transfer this x square over here, so it will cancel with this x square. If you transfer this plus c square over this side, it will become minus c square, and here plus c square is there, so it will also cancel. And this minus 2cx, if you transfer over here, it becomes plus. So here 2cx is there, and this you are transferring, so plus 2cx. This x square will cut, c square will cut, so here remains 4a square plus here 4a square root of x minus c whole square plus y square. Now this one 2 plus 2 gives you 4cx. Okay, all have got 4. Here a is there, here a is not there, but let us divide each term by 4a. So when you divide by 4a, 4 will cut, but a is not there, so you will get here 6cx by a minus 4a will cut, so 1a remains, so minus a equal to this 4a will cut, so in the square root x minus c whole square plus y square. To remove this square root, you square again both the side. So when you square here, it will come cx by a minus a whole square equal to this square root will cut, so x minus c whole square plus y square. You expand using a minus b whole square, and this also a minus b whole square. So here c square x square by a square minus 2 times cx by a into this a plus a square equal to, here also expand, x square minus 2cx plus c square plus y square. See here a and a cut, so here you get minus 2cx, here also minus 2cx. So if you transfer this minus 2cx this side, it will cancel with this. Okay, this x square you transfer over here, it is positive, when you transfer it becomes negative. So here c square x square by a square minus x square. Okay, this you transfer and cancel. Then this a square also transfer over here, it becomes negative. So c square minus a square, and this plus y square transfer over here becomes negative minus y square. From these two I am taking x square common, plus I am taking LCM here. So c square minus a square divided by a square into x square taking common. Okay, taking LCM. So here c square x square minus a square x square, but x square I am taking common. So here c square minus a square by a square into x square minus y square equal to c square minus a square. Now divide by c square minus a square. So when you divide here, this numerator will cut, remains only this and this one. So x square by a square minus, when you cut here, y square divided by c square minus a square equal to, when you cut, it will cancel, so it remains 1. Okay. Now this c square minus a square equal to b square. Okay, the relation between b, c and a is given as b equal to square root of c square minus a square. If you square, then it will come b square equal to c square minus a square. So now you can put the value, instead of c square minus a square, we can put as a b square. So put here x square by a square minus y square by c square minus a square. This value you put as a b square. So put b square equal to 1. Okay. So we can say that any point on hyperbola satisfy this equation, x square by a square minus y square by b square equal to 1. Conversely, let pxy satisfy the above equation. Okay, that is this equation what we proved just now. So it can satisfy this equation. If this satisfies this equation, then let us write in terms of y. Okay, y square. So this y square divided by b square transfer over here, and this one transfer over here. So this is negative, when you transfer over this side it becomes positive, and then 1 when you transfer it will become negative. Okay, so you can write like this, y square by b square equal to x square by a square minus 1. Okay, now this b square transfer over here, so b square in the numerator, and this a square take LCM. So you get y square equal to b square into, when you take here, x square minus a square by a square. Okay, let us take pf1. Now pf1 already we have proved here. Okay, we have written this formula. pf1 is this one, okay, this and this one. So this final one I'll write under the square root of x plus c whole square plus y square. So I'm writing here under the square root x plus c whole square plus y square, and y square value will place this under the square root x plus c whole square plus b square, this value x square minus a square by a square. Okay, I am taking LCM and taking this 1 by a square out of the square root, it will become 1 by a. So 1 by a, and this multiply here, so a square x plus c whole square plus this b square value again from here what I placed before, b square is equal to c square minus a square, this one. Okay, or before I gave you the relation, that one. So you can put the value of b square as c square minus a square, and this x square minus a square as it is, and this after taking the LCM I have taken out. Okay, so this a square will not be there. Now 1 by a as it is, a square as it is. This you expand using a plus b whole square, so x square plus 2cx plus c square, and this both the bracket multiply inside, so plus c square x square minus c square a square minus a square x square minus a minus plus a square into a square is a power 4. Okay, these you multiply inside, so 1 by a under the square root a square x square plus 2cx into a square plus a square into c square. This all the term as it is, c square x square minus c square a square minus a square x square plus a power 4. Okay, now we can cancel a square x square positive and a square x square negative. Okay, then a square c square positive and a square c square negative, so it will cancel. What remains is a power 4, we can write as a square square plus this one 2 square 2a square cx. Okay, and this one plus c square x square. Now this can be written as the perfect square of a square plus cx whole square under the square root. So square root and square cut, so you get pf1 value as this a I am multiplying, so a square by a gives you a plus this you multiply, so cx by a, c by a into x. Similarly, we can prove that pf2 equal to a minus c by a into x. Okay, so similarly we can prove, we just directly write instead of plus it will come minus. Now hyperbola c greater than a. Okay, I already gave you that c for hyperbola is always greater than a. So here c is always greater than a. So what we can say is that p is right of line x is equal to a. Okay, so this one is p is at right of x is equal to a. So this is my x is equal to a line and it is right side. Okay, so this side. So right of x is equal to a. That means x is greater than a. That means c by a into x is greater than a. Therefore, a minus c by a, x becomes negative. So p of 2 can be written as this one, c a x minus a. So c by a into x minus a. Okay. So pf1 minus pf2, the difference equal to pf1 value, this value a plus c by a into x minus pf2, this value c by a into x, this minus, but here minus is there, this minus, it becomes plus a. These two terms cancel, so get a plus a is 2a. Right, that means we have got the difference constant, that difference is 2f, right? 2a. Now if p is left of x equal to minus a, okay, now p we have taken here, right? But suppose it is this side, on this side, right? If it is this side, that means it is left of x is equal to minus a. Then what happens is, if it is so, that means you will take pf1 equal to minus of a plus c by a into x. Okay, that means pf2 will be a minus c by a into x, and if you find pf2 minus pf1, again you will get 2a. Therefore, any point that satisfies x square by a square minus y square by b square equal to 1 lies on the hyperbola. So we can conclude that the equation of a hyperbola with origin 0, 0 and transfer axis along x-axis is x square by a square minus y square by b square equal to 1. Suppose you have got this a and b are same, then you call that hyperbola as a equilateral hyperbola. We have proved this when the transfer axis is along x-axis, but suppose it is along the y-axis, then we can prove similarly y square by a square minus x square by b square equal to 1 can be derived. Hyperbola is symmetric with respect to both the axes. Then foci is always on transfer axis. So foci will be always on the transfer axis, and hyperbola, just like ellipse, symmetric to both the axes. It is the positive term whose denominator gives the transfer axis. So the term among these two which is positive, that will give you the transfer axis. Okay, for example, x square by 9 minus y square by 16. So the positive term among this is this one, right? So this gives you the transfer axis is along x-axis. So x is positive, so you can say transfer axis is along the x-axis, and the length of the transfer axis will be 2a. So a is 3, so 2 into 3 is 6. Okay, and another is along the y-axis is y square by 25 minus x square by 16 equal to 1. So positive term. Okay, so positive term is y. So the denominator of this gives you the term gives you the y-axis. Okay, so this will give you the transfer axis is along the y-axis. Okay, and the a value is 5. That means the length is 2a equal to 2 into 5 equal to 10. Okay, so this is what the one is along the x-axis, one is along the y-axis. So you have to see that positive denominator will give you the transfer axis. Latus rectum. Latus rectum of hyperbola is a line segment perpendicular to the transfer axis through any of the foci and whose endpoints lie on the hyperbola. So just like the previous cases, latus rectum is a line segment which is perpendicular to the transfer axis and it is passing from the foci and the two endpoints lie on the hyperbola. And the length of the latus rectum is given as 2b square by a. It is same like the ellipse. In this figure you can see that this is the transfer axis is on the x-axis, okay, and this transfer axis is along the y-axis, okay. So these are the two types, and this is the equation x square by a square minus y square of b square equal to 1, and for this it is y square by a square minus x square by b square equal to 1. So these are the two types of hyperbola. We'll keep this much for today. Thank you very much.